This video is going to feel an awful lot like math class. That's because we're talking about the math class. We're going to do a little bit of coding, volume of a sphere, and I'm going to end up doing this compound interest code in a different video. So let's talk about the math class. That's a utility class that defines methods or commands. We actually know some commands, like systemout.println. That's a method, right? Systemout.println is effectively the command that we use to print to console. We know what next int, next double, next line. Those are all methods that scanner can do, effectively commands, operations, for performing basic numeric operations, right? So the math class is going to define several of these things. The math class is included in Java by default. What do I mean? You are not going to have to import this. When we were working with scanner, we had to have an import statement. Not the case here. We're working with code that exists somewhere else, and it's included already. You don't have to actually bring it in. An API, Application Programming Interface, you don't have to know what that means. An API exists for all of Java's pre-built classes, things like scanner, math, string. We'll talk a lot about string later. That details the methods each class can perform. Let's take a look at the Math API. It's effectively documentation, a list of everything that it can do. I'm going to look at method summary. You may have heard of the word method. You may have heard of words similar to method. Procedure, function, method are all interchangeable. For us, they're actions. They're things that can be performed. But if I go down this list, let me show you just real quick how to kind of read this site. This is the actual name of the method, right? Abs, which you can guess, gives you an absolute value. All right, we see arc sine, cosine. So that's how you kind of read the name. Over here is the value that is returned. Now, what does that mean? Well, these commands often take in an input, and they're going to return or spit back out an output. Let's see if I can kind of do an example here. We'll look at abs. All right, abs is going to take in a double as an input. That's what these parentheses mean. And what it's going to do is return or spit back out a double. Right? In theory, that is the absolute value. Maybe I can find floor. I think is an interesting concept. We don't maybe hear a lot of. Floor is like rounding, except you always go down to the nearest integer, right? So in theory, we take in a double, we'll take the floor of it, and it's going to be a rounded double where it's been rounded all the way down to the next whole number effectively. So that's effectively how you read this, right? We got the name, we got some type of input, and then we have the output data type. Sometimes they can take in multiple inputs, but they're only going to spit back out one output, right? Max is actually one that we'll talk about in just a moment. Takes in two doubles. It's going to spit back out only one. Return. Let's use good language here. Okay, back to our slides. Some of that's not super important, right? You don't have to be able to read the API, but when you get curious, you know, it's the weekend, you want to get down on the Math API, you can thank me later. So these are some methods that I kind of recommend that you know. I'm expecting you to know, right? We see abs, which was the absolute value as we saw, returns the absolute value of the specified int. Specified in this case means what you're passing in as a parameter, as an input. Right? This method, this command is going to take in one integer. It's going to return an integer. Here we see abs again. It takes in a double. It's going to return a double. Right? The data type basically changes which version you're using. This is actually a technique called overloading. We'll talk more about overloading later, but I have two methods with the same name. For you, it's going to be a seamless experience. Right? If you want to work with integers, you just work with integers. If you want to work with doubles, you just work with doubles. Here we see POW. This one's awesome, right? We talked about, I guess, with moon weight. How do you do exponents? POW is how we do our exponents in Java. You see it's going to take in two doubles, return 1. Round takes in a double, returns a long. I won't worry too much about what a long is. It's a super large integer, but we're going to round it to the nearest whole number. Max takes in two integers, and there's actually a version that's going to take in two doubles. I think we saw that just a moment ago. Max takes in two integers, returns whatever the largest of those two are, and then of course min does the opposite, takes in two integers, returns whatever the lesser of that is. SQRT is how we do our square root of a number. And then lastly, pi, you'll notice that this doesn't have parentheses. That's because it's not a method. It's not a command. It's just a value. All right? We have this variable that is stored in the math class, and I can access it from anywhere just by referencing it. Let's talk about each of these methods. So POW is what I'm going to talk about first. It is used to evaluate exponents in Java. The first specified double is going to be our base, whereas the second one is going to be the exponent. Here it is used in context. The way I end up using this method is saying Math.pow 2, 3. So this is a base of 2, an exponent of 3. This is going to return or output a result, which I'm then saving into an integer, a double called x. We can see that whenever I print x, it's going to have the value of 8.0, the result. Okay, absolute value. Here in this example, I'm specifying an integer, -4, that is an integer. It's going to give me back an integer. Right? We're going to figure out what the absolute value of -4 is, which is 4. That is being returned by this method, which I am saving in to integer x. So when I print off x, we can see it has a value of 4. Here, absolute value is overloaded. Abs is overloaded. I'm using a double. For you, the user, right? Abs, using an integer, I get back an integer. Abs, use a double, I get back a double. It's a seamless experience. If you give it a double, you're using the double version. If you give it an int, you're using the int version. Okay, so we get the absolute value of 8.17. This method will return a double, which I'm saving into x. I print off x, and we see we have a positive 8.17. Round, this works just like you would expect. We're going to pass in a double here, 9.49. Right? That's going to round down. We're going to use the long data type. Don't worry too much about that. What I would just want you to know is that we do use long. We'll actually talk about why later, like much later, but we're going to get a long out of this. I am kind of demonstrating that by showing a long variable. That is one of our 8 primitive data types. And we did round down, right, to 9. We can see that in our comment. We're printing x, which should have a value of just 9. Note that methods will accept variables as well as literals. In all of the examples so far, I've just been throwing in a number literal whenever I'm calling the method. But we could, in theory, come up with a variable in advance. So here I'm taking 7.21 and saving it into test. Then when I call Math.round, I'm passing in test, the variable. I know that seems kind of mundane, but what I want you to think about is maybe test is not a hard-coded value. Maybe test is user input. Right? It's kind of one of the main reasons that we've enjoyed variables so far is that we can use them to store user input. So I'm passing in the variable. We get a result back of 7, which I then print off. Okay, here again, I'm kind of showing that you can mix and match. I'm using the max method. Max is going to give you the larger of 2 integers, right? And what I'm doing here is I have a number literal 7, and I have test, which is a variable. I want to know what is the larger of 7 and test, which has a value of 2 at this point. Math.max would determine that 7 is the largest, and then save that into x, and that's what we print off here. Max is also overloaded. Here in this example, we're going to take in 2 doubles. We'll determine what the larger of the 2 doubles is. That value gets returned by my method. I'm saving it into this double. that we print off. Min figures out the minimum between two values. Here in this example, we're doing the minimum of two integers. I want to know what is the minimum between negative 14 and 14. Min would determine that, return it. I'm saving the value that's returned into my variable x and printing that off. Here in this example, I'm using two variables, again, showing you that you can kind of mix and match the combinations here, as long as you're providing it the data types, right? I need two doubles in order to use this particular min method. The data type of test is double, the data type of test 2 is double. So I am passing it two doubles. Min will determine what is the smaller of those two variables, return it, which I'm then saving into x and printing off. Here I'm looking at square root. I'm specifying a value of 9. Square root of 9 is going to be 3. But notice here something a little bit tricky, right? Here, the notation says that this takes in a double as a input, as a parameter. I gave it 9, which is an integer. We can do that. And I want you to think back to whenever we created some variables, right? We've created double variables before and saved whole numbers, saved integers into them, no problem. That's effectively the same thing here. I can save an integer into a double, so this works. I want you to think about the vice versa though. What if this said int and I tried to give it a double? Can you save double values into integer variables? No. So the reverse of this doesn't quite work. Here we're passing in 9, an integer. It's going to be treated as a double once it's inside of the method. This method would determine that 3 is the square root of 9. Return it, which I'm saving into my variable, specifically 3.0 because it is going to return a double. Okay, a quick note on how to read these things. This is called a method signature. What this is saying, and we're going to highlight this over and over again, so if you don't get it now, it's okay. If you don't get it by the time of the test, that's okay because it's not actually on the test. But the sooner you kind of get a hold of this concept, probably the better. This method, called SQRT, is coming out of the math class. It takes in as inputs, parameters, one double, and it returns a double. The underline, not going to be super important, but the underline means it's static, and I'm not even going to tell you what static means. But that's what the underline means. Here's another example. We're still working with square root, SQRT. I'm passing in a negative 4. Interesting to note that you can't do the square root of negative numbers, or you get imaginary numbers, and we would print NaN in this case, which means not a number. Pi is not a method, a command. Pi is a variable that is stored in the math class. Here, looking again at the method signature, we see in the math class, there's pi. Notice the lack of parentheses. Those parentheses indicate our inputs, our parameters. No inputs for pi. It's not a method. It's actually just a variable that's stored in the math class. But if you were to access it and use it, you're effectively getting a double. It's almost like it's returning a double. Note the underline. This is actually a static variable. Don't worry about that, but that's what the underline means. Here's an example of me using pi. It's coming out of the math class, right? And I'm saying pi here, I'm multiplying it by whatever Math.pow returns. So here, Math.pow of 6 and 2, this is 6 squared, and so we're multiplying those values to get our area. I'm saving those in, and we get something close to this. Okay, so with those math methods in mind, we're going to code volume of a sphere. Write a program, SphereVolume, that prompts the user to enter a radius, then prints the volume of a sphere using the user's input. And here is the formula for the volume of a sphere. It is 4/3 pi r cubed. So a lot of stuff going on here. I'm going to code this one right now. It might be a good spot to pause if you want to try this on your own, however. So I have IntelliJ. I'm going to make a new project by going to File, New Project. My JDK is already selected. We'll go Next. We'll go Next. And I need to change my folder because we're currently in CSA. You are likely already in the correct folder, so you can just go ahead and name your project SphereVolume, and IntelliJ will make you a subfolder. I'm going to switch folders real fast to hop to principles, but I'm going to ensure that I have a subfolder to help keep our code organized. We'll finish. It's going to tell me it's going to create that folder, and that's perfectly fine. I'm going to expand my project folder, right click on the SRC, do a new Java class called SphereVolume. Okay, we're going to plug in a main method, public, static, void, main, string with a capital S, brackets, args. I'm going to declare a body with our braces, and we're inside the body of the main method. As our prompt kind of talked about, we're going to want input from the user. So I'm going to go ahead and implement scanner. First step, import statement. We're going to bring in java.util.scanner with a capital S. Second step, construct our scanner object. I like the name input. Okay, left-hand side, we're creating a scanner variable. This is a scanner variable called input. Right-hand side, I'm actually making the object. This is a particular scanner that's going to read from the keyboard. And then we're saving that object into this variable using the assignment operator. My third step is to prompt the user. I'm going to use an SOP, system.out.println, in order to do that, and I'm going to say, please enter a radius. Now that's going to seem kind of weird out of context, so what I would probably actually do in practice is tell them kind of what the program is or does using a system.out.println. Doesn't necessarily matter where, right? As long as it comes before this one, it doesn't matter where. I could have easily put this system.out.println after I created my scanner object. So I'm going to use a print line to say this program calculates the volume of a sphere calculates the volume of a sphere, and I'm going to use multiple system.out.print lines here to make a new line using a radius. So I do this so whenever I ask for a radius, it's not just like, whoa, why? You know, if you try to show this to someone, you kind of want to lead them into it. You know what I mean? If you just gave them this program and it said, please enter a radius, they don't know what's going on. Okay, so this program calculates the volume of a sphere using a radius. Please enter a radius. Something like that. This is effectively my third step to implementing scanner. My fourth step is to actually get the input from the user, and I want you to think about what data type, right? We want to be efficient with our data type. In this case, I think double makes the most sense, so I'm going to create a double. I'm going to call that radius. It's going to be equal to input, that's the name of my scanner, dot next double. Okay, so I've implemented scanner, right? Step 1, step 2, step 3, step 4. We're getting a radius from the user. I'm now ready to kind of calculate the volume. I'm going to use a variable to save the result and kind of keep my program clean, right? And I want you to think about what volume is. One thing I would consider is using a comment here to try to, write out how you would normally express the equation. That equation in question is 4/3 pi times radius squared. 4/3 pi, maybe we are actually going to use our multiplication here, 4/3 pi times radius, not squared, cubed. Right? Maybe in practice we're thinking just like r. So here is our equation, 4/3 pi r cubed. I need to translate this into Java code. Well, 4/3, that's pretty easy, right? We're going to do 4 divided by 3. Now, pi is a new one, right? Math.py is how I will actually access that value. It's coming out of the math class. It's not a method, so there's no parentheses here. It's just a value. It's a variable that I'm accessing out of the math class. Now, I'm doing this on purpose, right? Because we played around with some math stuff before. I'm talking about literal calculations, and discovered that if we want multiplication, we need to explicitly state it using an asterisk, right? This is how we're going to end up multiplying. If I just put things in parentheses next to each other, that will not do multiplication the way that we want. Sometimes that notation is used in English and math, in actual IRL math, but not here in Java. We have to explicitly state it with an asterisk. So I'm going to do 4/3 times math.py times our radius cubed. Now, you could multiply that out, right? We could use parentheses and say radius times radius times radius. But we actually just learned a method. That method is Math.pow. That's how we do exponents. Pow, as IntelliJ is clearly showing us, takes in two doubles, A and B. A, in this case, is our base. So what is our base? It's radius. So I'm going to pass in, as one of the inputs, radius. We'll use a comma to separate those values. And my second value, hard-coded, just a simple 3. And we'll end this statement with a semicolon. So here is my formula expressed in Java. 4/3 pi r cubed. Right? 4/3 times math.py times math.pow of radius cubed. This is going to multiply this out. I'm going to get a value back, which I'm saving into volume. Let's print this off using a systemout.print line, and I'm going to annotate it. I'm just going to say volume plus my actual variable. Okay, I'm going to run it. My very first time, so I'm going to right click in free space and tell it to run. This program calculates the volume of a sphere using a radius. Please enter a radius. I would actually maybe consider using this on one line. I thought it was going to be too much, but it actually looks okay. Let's stop it and run it again. There we go. This program calculates the volume of a sphere using a radius. Please enter a radius. Notice I got this stop button. It's waiting for me to enter something. I'm going to test it. I don't know, 7. Our volume came out to be 1,077. Perfect, right? I would never just assume that. Okay, so I'm going to use the Google volume of a sphere. Why am I using the Google? Because the Google actually has a calculator right here. We're going to use this to kind of check our code. I'm going to throw in a value of 7, and I should be getting 1,436.67. So what went wrong? I know a lot of you are already well ahead of me, and IntelliJ, being one of those, right, has highlighted this yellow from the get-go. What's going on here? I have integer division. There is a chance for truncation. 4 divided by 3 should be 1 point something. But because I have division between two integers, this is going to truncate to just 1. Right? So I'm using 1 times the rest of my equation. What I'm going to do is change one of the operands to a double by just simply including a 0.0. It doesn't matter which one, and you could do both. I would probably do both in practice because I like the consistency of it. Let's try this again. I'm going to run my program. I'm going to give it the exact same value of 7, and we get 1436, which is what we should be getting. Ours is actually a little bit more precise, right? Because we have all of this out here, because math.py is pretty good. much better than using something simple like 3.14. That's going to be it for our introduction to our math class. Tune into the next one where we're going to be doing compound interest.